Okay guys, so welcome ulit sa ating YouTube channel. Ito na yung lesson 26 sa ating sa ating Advanced Calculus 1. So, ayusin ko lang, nagulo yung phone. So, diinan ko lang. Okay, so ito na yung lesson, no? So, this is the properties of differentiability. So, ito yung, nandito yung power rule, nandito yung sum ng derivative, nandito yung product rule, nandito yung quotient rule. Okay, so let's have the properties. So, proposition number 2. So, proposition number 1 is all about Caratidori lemma. So, naalala nyo yun. So, proposition 2, if f is differentiable at x is equal to c, then it is continuous at x is equal to c. Okay, so paano yung proof nyan? So, napakasimple lang ng proof. So, dito ko lang lagay. So, since f is differentiable at c, yun yung basa dyan, by Caratidori lemma, per Caratidori's lemma. Okay, so there exists f sub 1 mapping from domain going to real number, okay, such that f of x minus f of c is equal to x minus c times f sub 1 of x. Okay, so for all x element of D. Okay, so consider to. So, ang gagawin ko na lang, so, kunin ko si f of x kasi tinatanong, no? Then, it is continuous. So, therefore, f is continuous. Then, f of x is equal to, this is just f of c plus x minus c times f sub 1 of x. So, kung napansin mo, this is continuous at c kasi f of c siya. So, this is continuous at c. So, continuous at c. Tapos, ito naman is also continuous at c. So, ito ay linear function, yung x minus. So, ito ay linear function. So, alam natin ang linear function is always continuous at any. Tapos, ito yung f sub 1 of x is also continuous at c. Okay, so therefore, yung product na ito is continuous. Yung sum nila is continuous. Therefore, f of x is continuous at x is equal to c. So, that is done. Okay, so ganun lang kasimple gamitin si Caratidori lemma. Ngayon, gamitin natin si Caratidori lemma para sa proposition number 3. So, ito medyo mahaba. So, next is we have the proposition number 3. So, papabuntong hininga ka na lang sa haba. So, let D be a subset of real number and C element of D, meaning C is the interior point. So, F and G mapping from D going to real number is both differentiable at C. Then, number 1, or letter I, F plus G is differentiable at C. And, baliktad to. So, and F plus G prime of C is equal to F prime of C plus G prime of C. Next, Rf is differentiable at C, and Rf prime of C is equal to Rf prime of C for all R element of real number. Then, F times G is differentiable at C, and that is F of G prime of C is equal to F prime of C, G of C plus F of C times G prime of C. So, parang ito yung UDU plus BDU. No? So, parang UDU, ito yung UDU plus BDU. Ano lang yung ayos. Okay, next is f of c is not equal to 0, then 1 over f is differentiable at c, then 1 over f prime of c is equal to negative f prime of c over f of c squared. So, ito yung mga negative 1 over x, negative 1 over x cube, ganun yung differentiable niya. Tapos, isisingit ko dyan si quotient rule after nyan. After ko ma-prove, ipoprove ko si quotient rule. Yung f of g, so yung ud, yung derivative ng u over b is equals sa bdu minus udb over b squared. Then, plus the f of c is greater than 0, then f raised to 1 over k is differentiable at c, and f 1 over k raised to c is equal to 1 over k, f raised to 1 over k minus 1 of c, then f prime of c. Okay, so ito yung parang yung nth root of f. So, kunyari, nth root of f nyo, yan yung differentiable nyan. So, hindi kayo ipoprove kasama sa problem set kasi yan. Okay, so per assumption, dito ka nasulat lahat ng assumption, ipoprove kasi natin yung buong proposition 3. So, ito yung proof. So, sulat ko muna yung assumption natin. Since f is differentiable at c, so this is if and only if. So, by Caratidori lemma, there exists f sub 1. So f sub 1 mapping from D going to real number such that f of x minus f of c is equal to x minus c times f sub 1 of x. Okay, next. Since G is differentiable at C, that is if and only by Caratidori lemma, there exists G sub 1 mapping from D going to real number pa rin such that G of x minus G of c is equal to x minus c times G sub 1 of x. So this is for all x element of D. Okay, so ito yung mga assumption na gagamitin natin. So next is ipoprove ko si I, 2, 3, and 4. Okay, then kasama si quotient rule. Okay, so ito blanco papel. So naglaan talaga ako ng blanco para doon. So for I, so gamit yung mga assumption. So consider natin to. So consider si una, si f of x plus g of x. Okay, minus f of c plus g of c. So kasi pinoprove natin yung sum nila. Dapat differentiable. So yan yung consider natin. So this is equal to, aware kayo na mapagpasasama natin si f of x minus f of c. Okay, then plus g of x minus g of c. Okay, note by Caratidori lemma. So inassume natin, kung meron akong f of x minus f of c, that is x minus c f sub 1 of x. Meron akong x minus c g sub 1 of x. Para din naman sa isa. So applying yung assumption natin, yung hypothesis natin na nag-gather, this is f sub 1 of x tapos x minus c. So baliktad, sorry. Then this is x minus c tapos g sub 1 of x. Tapos factor out natin x minus c. This is x minus c multiplied by f sub 1 of x. Okay, so f sub 1 of x plus g sub 1 of x. So note na ito yung ating increment function. So kung napansin mo, ito yung increment function natin. So increment function. Okay, so check natin since f sub 1 and g sub 1 is continuous at C, by property of continuity, f sub 1 plus g sub 1 is also continuous at C. So pwede natin kunin si f sub 1 of C plus g sub 1 of C. Okay, which is equal to, ano sabi? Yung f sub 1 of C, this is just equal sa f prime of C plus g prime of C. So therefore, yung f of x, so therefore yung f plus g prime of c is just equal sa f prime of c plus g prime of c, and this is done. Okay, so para yan. Okay, next is for number 2. Ano ba yung 2? Yung 2 is rf, no? So for 2, lagyan ko na ng red. So for number 2, so yung kinukuha naman natin is rf lang, no? So napakasimple lang. So sabi, we have rf of x minus rf of c. Okay, then obviously this is just equal sa papactor ko yung r, tas may matitirang f of x minus f of c. Then by Caratidori lemma, may definition tayo dyan. That is equal sa r, okay, times x minus c times f sub 1 of x. Okay, so factor out ko lang. This is x minus c multiplied by r f sub 1 of x. So note, ito yung increment function natin. So lagay ko lang, ito yung inf, increment function. Okay, so since yan yung increment function natin, anong gagawin natin? Since f sub 1 is continuous again at C, then by property, r f sub 1 is also continuous at C. So pwede natin kunin si r f sub 1, no? So pwede natin kunin dito ng duktong, no? So pwede natin kunin si RF sub 1. Ano yan? RF sub 1. So therefore si RF prime of C is equal sa RF sub 1 of C, or simply this is RF prime of C. Okay, and that is done. Okay, so ganun yun nangyari. So again, sabihin mo muna na continuous kasi kasama sa Cartesian dilemma, kung continuous f sub 1, kung continuous increment function, therefore pwede mo i-apply yung kanyang conclusion. Ayun yung isa sa mga criteria ni Cartesian dilemma. Okay, next is for number 3. Ano ba yung number 3? Ayun, yung product rule, no? So, ano ba yung number 3? So, ito medyo mahirap. F times, so f of g, so f times g of c is equal to f prime of c, g of c, plus f prime of c, g prime of c. So, check natin paano gagawin dito. So, consider natin ulit si test 3. So, dito na, no? 3. So, this is for 3. So, consider si f of x, g of x, minus f of c, minus g of c. So, dito, hindi tayo basta-basta pwedeng pumanat na self-factor out kasi walang common literal. Ngayon, ang gagawin natin, mag-add and subtract tayo ng 0. So, mag-add tayo ng 0 dyan. So, kumbaga, mag-add tayo ng 0 term na kung saan siya equivalent dito. So, add natin to sa gitna. So, ang gagawin ko, this is just f of x, g of x. Tapos, mag-add ako, susubtract ng f of c, g of x, tapos plus f of c, tapos g of x. So, ito equivalent sa 0 yan. Nag-add lang ako. Minus f of c, g of c. So, ayun yung discarding gagawin kasi na sir. Next, kuha na tayo na pwede mag-factor dyan. So, obviously, no, ito, grouping to. Ito, group to. Kasi f of c pares makuha dun to, g of x. Okay, so dito, equivalent to sa g of x multiplied by f of x minus f of c. Okay, then plus, ang itira, f of c, pa-factor out ko dun, f of c multiplied by g of x minus g of c. Okay, then by Cartesian dilemma application, this is just equal sa g of x multiplied by x minus c, f sub 1 of x plus f of c, okay, multiplied by x minus c times g sub 1 of x. Okay, then factor out latency, x minus c. So, this is x minus c. So, may natira na lang na g of x, f sub 1 of x, plus f of c, tapos g sub 1 of x. So, note na ito yung ating increment function. So, napansin nyo, ito yung ating increment function. So, ito yung increment function. So, since yan yung increment function, so, aware tayo, si g continuous, si f sub 1 continuous, si f of c continuous, si g sub 1 continuous at c. So, pwede ko nang right away tuloy na lang, no? So, ang gagawin ko na lang, we have f times g prime of c is just equal sa g of x. Okay, so that is g of c, tapos f sub 1 of c, plus f of c, tapos g sub 1 of c, which means this is equal sa g of c, tapos yung f sub 1 is f prime of c na lang, plus f of c, tapos g prime of c. Kung napansin mo, that is udb minus bdu. Tama? udb plus bdu. Ayan yung kanyang derivative. So therefore, this is differentiable. Okay? Then last si 4. Kung natin si 4. So, anong kulay? So, 4, no? So, hindi ko na papakita si quotient rule, sayang. Pero gawa tayo scratch para mapakita ko si quotient rule. Gusto ko kasi mapakita talaga si quotient rule, to be honest. Okay, so for number 4, medyo haba, no? Si number 4 yung 1 over f of x. Okay, so 1 over f of x. So for number 4, consider natin si 1 over f of x minus 1 over f of c. Okay, so obviously, that is equivalent lang sa f of c minus f of x over f of x tapos f of c. Okay, factor out natin negative. So, this is negative of f of x minus f of c. Okay, then all over f of x minus f of c. Okay, then by Caratidori lemma, this is negative of x minus c tapos f sub 1 of x over f of x tapos f of c. Yes, labas lang natin yung x minus c. So this is x minus c multiplied by negative f sub 1 of x over f of x tapos f of c. Okay, so this is for all x element of t. So note, continuous to sa c, continuous sa c, continuous sa c. So pwede na tayo mag right away, punta na doon. So since continuous siya, therefore ano mangyari, yung 1 over f prime of c is equal to, kunin ko yun, that is negative f sub 1 of c over f of c times f of c, in which that is negative f prime of c over f of c raised sa 2. So that is done. Okay, kasi ayun yung ating conclusion. Check natin. Yan, nakuha ko siya. Okay, so ganyan mag-prove ng property ng ating derivative. So hindi ko po prove yung number 5 kasi mag-serve as assignment sa inyo yan. Okay, next is by the power rule. So kunyari f raised to n prime of c, that is n, f raised to n minus 1 of c, then f prime of c for n element of natural number. So ito ay sa problem set. Then ito ay by mathematical induction. So by mathematical induction pwede siya ma-prove. So yun yung mga suggestion na pwede kong sabihin dyan. Okay, so again, sasama ko dito yung quotient rule. Naglagay na ako ng scratch. So by quotient rule, so ano yung quotient rule? Pati spelling, nakalimutan ko na. This is quotient rule. So quotient rule is f over g prime of c. Okay, so kailangan natin makuha yung derivative niyan. So paano yung quotient rule dito? So f over g prime of c. So pwede kong gawin ganito. So this is equal sa f multiplied by 1 over g prime of c. Okay, then by property number 3, so sabi ng property, yung f times g prime of c, that is equal sa g of c f prime of c, or sundin na natin yung form dito para hindi tayo malito. So sabi, yung f prime, f g prime, yung f times g prime of c, that is f prime of c tas gc. So dito mangyari, since product, so ito ay magiging f prime of c tapos 1, so this is 1 over g of c. Okay, ito yung isa din, plus f of c tapos 1 over g prime of c. Okay, so next is apply natin yung nakuha natin dito. Yung 1 over f prime of c is 1 over g prime of c. So this is just equivalent sa f prime of c tapos 1 over g of c plus f of c multiplied by negative g prime of c, kasi ganun mangyari, then g of c raised sa 2. Okay, so ayun yung nangyari dyan. Okay, so in-apply ko yun dun sa g. Okay, so next na gagawin, ano pang gagawin natin dyan is, I think, i-cross multiply. Ngayon, hindi pala problema pala natin yung 1 over g, no? 1 over g prime of c. Ano ba yung 1 over g prime of c? Yung 1 over g prime of c, equivalent lang siya sa 1 over gc. So, ito ay just equivalent sa f prime of c over g of c. Okay, kasi wala namang 1 of c. Okay, then plus ko lang siya dito. So, plus f of c multiplied by negative g prime of c over g of c square. Okay, then kung natin na LCD is g of c square. So that is equivalent lang sa ilalim is g of c raised sa 2. Okay, then multiply doon, that is f prime of c tapos g of c, kasi isa matitira. Okay, then this is f of c, cancel lahat yung g of c. So this is just minus f of c tapos G prime of C. So ayusin ko lang konti. So this is just G of C, F prime of C, minus F of C, tapos G prime of C, all over G of C square. So napansin mo, ito yung B du minus U dB over B squared. Okay, whenever ito yung U, ito yung B. Okay, so ganun yun nangyari. Okay, so ganyan i-prove si quotient rule. Okay, next is let's have the proposition number 4. This is the chain rule. Ay, pang 5 video na kasi. Okay, so let D and E be subset ng real number for F mapping from D going to real number and G mapping from E going to real number where F of D is a subset of E. So ito yung parang composition of function. So kaya kay chain rule. So pasok dito yung composition of function. So suppose C is an interior point of D such that F of C is also an interior point of E. Okay, if F is differentiable at C and G is differentiable at F of C, then G circle F is differentiable at C and G circle F prime of C is equal to G prime of F of C of F prime of C. So paano ba itsura na ito in terms of diagram? So drawing ko lang ha. So assuming na ito yung D. Okay, let's say ito yung D. Ito yung G. Ito yung X. Okay, so ito yung E. Okay, so pag-apply natin sa function, siya si F of D. Okay, si F of D ang dyan yan, nasa loob na siya. Ito na yung F of X. So papasok kasi yung X dun sa loob nun. Yun, paglabas nun, siya na yung G circle F of X. Okay, so kung naalala nyo, ganyan yung drawing ng ating composition of function. So ngayon, ang problema natin, ipoprove natin siya using Caratidori lemma. Okay, so ito yung proof. So using Caratidori lemma, using proposition 1 na lang, or mas kilala nyo as Caratidori lemma, we have F of X. Since F is differentiable, sabi no, F is differentiable, we have F of X minus F of C is equal to X minus C tapos F sub 1 of X. Okay, then for all X element of D. So note, ito ay continuous at C. So we also have G of Y. So si G of Y is differentiable. Si G of Y minus G of F of C. Kasi differentiable siya naman at F of C. Kaya ganyan lalagay ko. So that is equivalent sa Y minus F of C. I think. Then this is G sub 1 of Y. So this is for all Y. Element naman ng E. Kasi domain na ng G yung pinag-uusapan. Okay. So magkaibang element na sila. So note that this is continuous at F of C. Ito ay continuous at C. Ito ay continuous at F of C. So combine natin yung dalawa. So combining this, okay, so we have G circle F of X minus G circle F of C. Okay, that is equivalent lang sa G of F of X. Okay, minus G of F of C. Okay, note by definition G of F and G, since siya ay continuous, this is just equal sa F of X, kasi yun yung kanyang Y, F of X minus F of C. Okay, kumbaga yun yung X minus C niya. Then, multiplied by G sub 1 of F of X. Okay, so ito yung increment function. Next, by definition of Caratidori lemma, this is equal sa X minus C times F sub 1 of X multiplied by G sub 1 of F of X. Note, ito yung candidate increment function natin. Okay, so ito yung increment function natin. So kung napansin nyo, yung F sub 1 continuous at C, yung G sub 1 of F of X is continuous at F of C. Kasi continuous F of X sa C, so therefore yung G sub 1 continuous na din sa C. Okay, so therefore pwede natin kunin yung kanyang derivative. So anong sabi doon? Ang derivative ng G circle F, okay, so ang derivative ng G circle F is just equal to, so therefore lagay ko na lang, therefore yung derivative ng G circle F prime of C is just equal dito yung increment. So ito yung F sub 1 of C, G sub 1 of F of C, in which palitan natin yung G sa buwan magiging G prime. So ito yung F prime of C, tapos G prime of F of C, in which ayun siya. Okay, nagkapalit lang. So therefore this is done. Okay, so ganyan i-prove si chain rule dito. Okay, so last for this video sa property. So let's have the proposition 5. So differentiability for inverse theorem. So sabi niya, f inverse prime of f of c is equal to 1 over f prime of z. So ayun yung sabi. So recall na lang natin, no. So paano siya ipoprove? Hindi naman totally ipoprove. Paano ba natin siya ipapakita? So recall na lang. Recall that f inverse of f of x is equal to x. Now, kung mo yung f inverse of f of x, that is equal to f of x. So, ano ibig sabihin nun? Pag kinuha ko yung derivative nito, so for example, so this is for all x. Okay, so kunyari kunin ko yung derivative niyan, ang magiging derivative niyan is f inverse prime of f of x. Tapos times chain rule pa, that is f prime of x, which is equal to 1. Okay, then kunin ko lang to. This is f inverse prime of f of x is just equal sa 1 over f prime of x, which is nakuha ko na. Nyari evaluate ko at c. So at x is equal to c, that is f inverse prime of f of c is equal to 1 over f prime of c. So therefore that is done. So ganun lang siya kasimple. Okay, then hoping na naintindihan mo yung mga properties, then hoping na mas naintindihan mo paano ginagamit si Caratidori lemma at ano yung napakagandang ginawa ni Caratidori lemma dito sa differentiability. So pinadali niya yung proving kasi nga meron siyang mga property na kung saan i-check mo lang kung continuity, kung continuous, yung sum ng continuous, yung product ng continuous, then gamitin mo lang yung differentiability na definition. So again, pwede natin i-prove yung mga property using yung definition of derivative pero mas mahaba. So ako, mas pinili ko si Caratidori lemma para ma-prove natin lahat yan. Okay, so thank you for watching. Hoping na panoorin mo yung mga next video pa natin dito.